Hello everyone, welcome to the session. I'm sure that you will be happy and will be doing great. So today we are going to learn a very interesting and as well as important topic. That is basically a theorem, right? So we will start it, right? So my name is Atul Kumar Singh and today we will learn about Pythagoras theorem. So basically I'll let you know what is Pythagoras theorem, and after that I'll let you know how to prove it. So if I'm talking about the higher grades, so you need to prove Pythagoras theorem by using similarity property, right? But if I'm talking about the lower grades, so you can prove it by using a square also. I'll let you know both of the methods, right? First of all, if I'm talking about, let us suppose I have a triangle over here, right? So this is a right angle triangle. So first of all, I'll let you know what is Pythagoras theorem. So according to the Pythagoras theorem, so what it is, this is your perpendicular, right? This is your base and this is your hypotenuse, right? And this is a 90-degree angle, right? Now suppose if I'm talking about the Pythagoras theorem, so Pythagoras theorem basically tells the relationship between all the sides of a right angle triangle, right? So according to this theorem, what we can say, the sum of a square of perpendicular and base, that will be actually equals to the hypotenuse square. So this is basically the Pythagoras theorem, right? And basically this is why this is very important, because you will be using it in your higher grades like in your trigonometry, right? And in mensuration you will be using it, right? So basically here you have three variables P, B and H, that means perpendicular, base and hypotenuse. So sometimes a simple question will be asked to you that any of the two sides will be given and you have to find out the third side. So it is quite easy. Whenever you will be given with the two sides, you can find out the third side, right? Okay, now so I tell you that already I told you that what is Pythagoras theorem. Now the thing is that how you will get to know how to prove it. So I'll let you know this one also. Suppose here I'm going to draw a 90-degree angle over here. That means I'm going to draw a perpendicular over AC, that is BD, right? So now let us suppose initially if I'm talking about this angle here, right? Initially if it was 90-degree angle, suppose it was alpha, so it was beta, right? Now if I'm talking about the smaller triangles, now first of all I'm talking about ABD, that means this smaller triangle. So here it is beta, here it is 90-degree, that means it should be alpha, is it? Why? Because suppose I'm talking about a bigger triangle over here, and here one triangle is 90-degree, one angle is 90-degree, one angle is beta and one angle is alpha. So what will happen here? If I'm talking about another triangle, right? So here also if one angle is 90-degree, one angle is beta, so definitely the third angle will also be equal, same as it is, right? That means it should also be alpha, is it? So that is why I'm saying here, if it is beta already, because this is in the bigger triangle ABC, that means it should be alpha. Now let us suppose if I'm talking about the smaller triangle, another smaller triangle that we have here, BDC, that means this triangle. So here if it is 90-degree, if it is alpha already, that means it is 90-degree, it is alpha already, that means this angle should be beta, right? Now how we can use this to prove the Pythagoras theorem? We need to use here similarity, right? So how we can do this? According to the similarity, you know, whenever two triangles are similar, so the corresponding sides of the triangles will be in the same ratio, right? That means suppose if I'm taking two triangles, the first is smaller triangle, that is ABD, and the bigger triangle ABC. So here basically I'm taking the side which is opposite to the 90-degree angle, that is AB, okay? And if I'm talking about the another side that I want to take, that is opposite to alpha, so that is here AD. Now the same thing I need to take from the bigger triangle also. That means this side was from opposite to 90-degree angle. So in the bigger triangle here B is 90-degree. So opposite to B, that is AC over here, right? So I'll take AC. Now here I have taken opposite to alpha. So in the bigger triangle also I need to take alpha, opposite to alpha. So that is AB here. So I'll write here AB. Now just we need to do the cross multiplication. So when we do the cross multiplication, so what do we get basically? AB whole square, that's going to be AC dot AD, right? This is your first equation. Now I'm going to take the second triangle, second smaller triangle, that is BDC, and the bigger triangle, that is ABC, right? Now again what I'll do, in the triangle, smaller triangle BDC, I'll take the opposite side, that is BC, right? And the side which is opposite to beta, that is CD, or we can write it as DC also, right? Now if I'm talking at the bigger triangle, so the side which is opposite to the 90-degree angle, that is AC, right? And the side which is opposite to beta, so here it is beta, and the opposite to it, that is going to be BC. Now let us do the cross multiplication. So what do we get here? BC square, right? And that is equals to AC dot DC, right? Now this is your second equation. Now what you will do, you will have to add equation first and second. So in this way you will be getting here AB whole of a square plus BC whole of a square. AB square plus BC square, that is equals to, now you will add AC dot AD and AC dot DC. So basically AC is common, so what I can say here, I can take AC as common. So from here I'll be getting here AD, is it? Yeah, very good. And from here I'll be getting here DC, is it? Okay. And that's a positive sign over here. Why? Because we are adding these two equations, that is why. Now here it is AB square and here it is BC square. So AB, that is what? That is perpendicular, so I can take it as B square, and BC, that is base square, that means I can take it as B square. And then AC, and here if I'm talking AD plus DC, so basically AD plus DC, that's gonna be AC, right? Is it? Yeah, very good. So that means I can here multiply it by AC dot AC. Now I can write it as AC square, is it? And what is basically AC? That's going to be your hypotenuse, right? So if I'm taking AC as H, so that's going to be H square. So this is the Pythagoras theorem, and this is the thing that we need to prove here, right? I'm sure that you get it right. Okay. Now the second thing is that how we can prove it by using a square. So quickly I will be telling you here. Let us suppose first of all what you have to do in the square, you have to divide all the sides in two equal parts, right? Suppose here I'm taking this place here, right? And suppose this is A and this is B, right? Now the same thing that I'll do here, suppose that's gonna be here B and that's gonna be here A. Again I'll be taking this one, that's gonna be your B here, and that's gonna be A. Again I'll take a point, and that's gonna be A here, B, and that's gonna be A. Now what I'll do here, I'll join all the points now, right? So I'll join this point, I'll join this point, I'll join this point, I'll join this point. So basically what you are having, if you, this is a square, and already we have taken a square, so it means here you will be getting 90-degree angle, all the angles that will be 90-degree angle, right? And basically if I'm talking about a triangle, let us suppose I'm talking about this triangle. So here it is B and here it is A. So let us suppose this is C. Now if we will talk about this, so this is also a right angle triangle, right? Here also you have one side A and another side B, that means it should also be C, is it? In the same way, if it is A, if it is B, and it's also a right angle triangle, that means it should also be C. And the same way you can say this will also be C. That means now you are having a square inside the square, right? Okay, now suppose if you want to write this area of the bigger square, right? Area of the bigger square. So area of the bigger square, that's going to be equals to area of 4 right angle triangles plus area of a smaller square, is it? Okay, so area of bigger square, so first of all you need to find out the side of the bigger square, that is A plus B whole of a square. If I'm talking about the side, so that is A plus B, right? So that means side square, that is A plus B whole square. Now area of one right angle triangle, so that is half multiplied by base. So what is basically, let us suppose I'm talking about this one, because all the triangles are equal, right? Whether I'm talking about this one or this one or this one, so the area are going to be same for everyone. So that's going to be base into height, that means AB, and because here we are having 4 triangles, that is why we need to multiply it by 4. 1, 2, 3 and 4. And then area of the smaller square, so here we have a square whose side is C, That means it's going to be side square, that means c square. Now 2 times 2, so what do we get here? And let us open it out. So a square plus 2ab, this is a formula, right? And then we get 2ab plus c square, right? 2ab and 2ab will be cancelled out. So now what do you get here? A square plus b square, that's going to be equals to c square. That's it, right? Basically, what is a? That's the base. What is b? That's the perpendicular, right? So you can see here perpendicular is whole square plus base square. Now what is c? So c is also hypotenuse, right? So this is the thing that we need to prove. That means the Pythagoras theorem. I'm sure that you get it right. Okay, understood? Okay, so now I'm gonna end the session. So bye bye, take care. If you are having any difficulties, so you can just type in the chat box. I'll be getting you. Okay, so bye bye, take care, be happy and be healthy, and see you soon again. Thank you so much.